Hello. This is another resource in the webinar library of the Community Microgrid Planning Academy at the Center for Resilient Design at the New Jersey Institute of Technology. My name is Marc Pfeiffer, and I'm going to bring you on a deeper dive into microgrid policy and procurement issues that were initially raised in previous webinars. This webinar is targeted toward non-technical people. This is the first of two webinars. It is an overview of the government context and risks that must be analyzed when a microgrid is being considered by a community. The second one looks at public policies and government procurement actions that need to be reconciled in order for microgrids to move forward in the state. Regrettably, they won't provide a lot of answers, but are intended to highlight the issues that need attention and resolution. So, let's look at an overview of community microgrids and public policies. Let's first look at the general concept we're talking about. It is how New Jersey can develop community, or as we call them, town center microgrids that will provide emergency electrical power for emergency services and support critical infrastructure in case where the electrical generation and or distribution grid is unable to provide power in a municipality. It does this by setting up a power distribution system that supplies locally generated power to those facilities when the electrical distribution company power supply grid is down or is undergoing peak periods of supply. That locally generated power can come from solar or wind-powered systems, combined heat and power suppliers, generators, biofuel, and stored energy systems. Once established, a microgrid must be regularly tested and used to ensure it will not fail. Equipment maintenance is performed and communications and technology systems kept up to date. Like a generator that sits still until it's needed, it needs to be periodically tested and stressed to make sure it will work when necessary. To date, microgrids have been very successful when a microgrid connects contiguous properties that are owned or managed by a single owner. We've seen that very successfully in universities or government complexes throughout the country. Extending the concept of the microgrid beyond those boundaries and involving multiple property owners and multiple suppliers of distributed energy, public rights of way is the new opportunity and challenge. So let's talk about this idea of the community town center microgrid and why a government would want to consider it. So what problem does that town center microgrid solve? The problem is what happens when the EDC grid goes down. The challenge became very evident from grid failures throughout the state during Superstorm Sandy. There were a myriad of local and system operator circumstances that led to that failure and what was an unusually slow recovery. Put at particular risk were vulnerable populations, seniors and those with medical conditions that require 24/7 power. But it will also compromise the ability of emergency responders to do their jobs, let hospitals operate as necessary, make sure gas stations can operate, and food stores can have supplies for residents. These are the challenges that we're trying to solve with a microgrid. The microgrid creates options for local officials to meet many of those responsibilities. The idea in many cases is to create one in a downtown area that can include public, healthcare, congregate housing, and food suppliers. Another value of a microgrid is during peak demand periods. Because it generates its own power through distributed energy resources, it can provide power when the grid is overloaded or provide power at a lower cost than is available from the grid. The development and operation of community microgrids has wide implications and risks that need to be considered and managed. But the first question, the kind of the bottom line of this whole thing is, will a microgrid solve a problem, or are there other solutions or a mix of solutions as an answer? Well, that is a core question, and we need to define the problem first. So let's say that the problem is one of providing electrical reliability in an area that historically has had unaccepted reliability problems. We can start with that. It could also be a variation or something else. It could be that you have a situation where power goes down, but you have because of risks that are in the community. Could be storm surges on a Jersey coast community. It could be situations like we had in Hoboken where substations were underground. We've had that happen in Newark and in Hoboken. However, PSE&G has been working to eliminate those problems. We also can be concerned if there are other individual or a combination of solutions that might better reach that goal of ensuring electrical reliability. For example, would new investments by the electrical distribution companies in hardening their systems and reducing their risks reduce the scope of the problem? Do critical businesses acting on their own to install their own generators have an impact that they help solve the problem? So identifying the problem in every municipality that wants to consider a microgrid is absolutely critical, because only then can a microgrid or any solution or set of solutions be assessed to reach those goals. So we have some challenges in developing that idea of a microgrid. So we think about first conducting a risk analysis. Who does the work and how are they hired? That's the procurement question. How do we finance the development and pay for the power and manage the operation going forward? These are some of the underlying questions that are going to have to be answered by any municipality that's thinking about doing a microgrid project. So our next question is, can this work in New Jersey? Well, first, New Jersey believes that microgrids can be a possible solution to power outages during emergency and high cost periods. And that's an important aspect that we have to think about. The idea of a community or town center microgrid is new, and it's not yet proven in practice. New Jersey is one of the states at the cutting edge of this. Other states looking at it include California, New York, and Connecticut and Maryland. And we have to think about that, because if it's not hasn't been done anywhere, how do we know what we're going to do? Well, it leads us to observe that at the end of the day, using the phrase "you don't know what you don't know" has some value to this. We also have to think about the fact that public policy is a very fluid and challenging opportunity, we'll say. Considering that it is fluid and moves rapidly over time, it is driven by political motivations, industry advocacy, public interest dynamics, experiences in other states, and technological advancements. Sometimes policy can get ahead of practices and vice versa. The challenge we face is to get the right policy in place at the right time and include policies that can reasonably anticipate the direction where a particular challenge is going. We also have to think about in New Jersey that our local governments are very heavily regulated. We've got over 500 of them, and because we have that, the state has determined over time that having some financial controls and contractual procedures in place makes sense to improve government integrity and responsibility. When it comes to hiring professionals or contracting for public improvements, we have a range of financial and procurement processes, construction contracting laws and regulations that, while they may be time consuming and sometimes considered a bit stifling, they have the attention and goal of ensuring an open process that focuses on fiscal integrity, ensures corruption-free contracting and is transparent to the public. So when we're talking about something new, we have to think about risks, and looking at risks is a good way to determine how public policies ought to be decided. So when we're thinking about microgrids, we have a number of risks we want to address, and the first one is public and political risk. We have to ask some questions. Do stakeholders have enough information to make informed decisions? Is enough known about the actions that an EDC is taking to reduce its risks of outage, which would reduce the potential need or capacity needed for a microgrid? Can public concerns be addressed when there's debate about moving forward with a microgrid? So in order to deal with that, officials need to be careful about the potential value of a microgrid is not being oversold or overly hyped. Because at the end, if the program doesn't work as planned, there will be political ramifications. Remember, the private sector is always willing to take on public work where risks are involved when that potential for loss, or if those risks are not something they can assume at a reasonable price. Well, we figure out a way to transfer that risk to the public sector, because they're the ones who benefit from it at the end of the day. Our next risk is financial, that are basically development and operational costs. Where does the money to develop a microgrid come from? What are the worst case scenarios that have to be managed? How will rates be set? And will consumers be willing to pay the ongoing charges to keep the microgrid available and the government pay for its costs when it is invoked? If the program doesn't work as planned, who is on the hook and for how much? The next risk is legal. During construction, there will be challenges where you're dealing with public right-of-way and public property. There will be supplier risks, making sure you have the supplies you need when you have to have them. There are challenges with public labor contracts, and we have to figure out how to deal with unanticipated consequences to prevent overruns. The microgrid will involve developing locally operated distributed energy sources. Will those owners and operations of the systems be compelled to make them available in an emergency when they may need them themselves? And how do we make that work? Their rights also have to be addressed for liability purposes in the event things don't work as planned. We then have to deal with construction risks. Can it be built without causing unresolvable disruptions and be done within budget? And what are the contingency plans for events that were not anticipated and deal with the potential for cost overruns? Operational risk. Once it's up and running, will we be able to maintain it? Will the funds be there to maintain and operate it and replace the system as necessary? If we're looking for something that's only going to be operated a couple times over a 10 or 20-year period, you have to make sure the system's going to work when necessary, which involves testing and dealing with and being able to respond when power supply is short during summer peak seasons. All of these things have to be managed in a way that hasn't really been done yet, and we need to figure out how to do it to make it work. And then there's the dealing with uncertainty. Accepting uncertainty and having alternatives in dealing with something new, there's always new risks. The first few places that invest in microgrids need to carefully consider how they approach the idea, and that so they'll act prudently to minimize their risks. We have to ask ourselves, just because we can, should. So this brings up the challenge of microgrids in risk management. Once risks are identified, there are common business and government risk management practices that can be used to assess them. This includes identifying, assessing, and analyzing the risks on the dimension from the last slides, those public and political, financial, legal, construction, operational, and uncertainty risks. The assessment has to be very location specific because the needs in one place will be different from the needs in other place. And you should really go through a very formal process of understanding what these things are. Because once you understand the risks, so once we've identified risks, we now have to figure out how we're going to mitigate them. Risk assessment will always lead to pathways to mitigate and manage risks. We can do that by finding ways to reduce the risk, transfer it to somebody else. For example, a contractor may want to transfer their risk to the owner, and the owner may want to transfer risk to the contractor. There are some risks we're willing to accept because we think they're not going to be it's not something that's going to happen to us, and there'll be some risks we're going to avoid by taking actions. The important part of that is that risk management usually has a price that is going to be borne by one party or another. It may be an insurance company, it may be the contractor. There's always going to be a price you're going to pay for those things. So at this point, we're going to end part one. On behalf of the NJIT Center for Resilient Design, we hope you found it useful. Part two will continue with an assessment of the public policy and procurement issues that need to be addressed as part of the state's microgrid development process. Thank you for listening.